Good afternoon, everyone. My name is Ragvi. Her name is Elena, Akshaya, Anirudh, Vaishnavi, Sankirtana, and Anvisha. Today we are going to tell about quantum computing. So quantum computing is introduced by David in 1985. He introduced the construction of logic gates for universal quantum computing. It is a multidisciplinary field which includes mathematics, physics, and also computer science, which solves complex problems for which our usual classical computers cannot solve. Uh, it utilizes mechanics to solve these problems. Um, logic utilizes mechanics. It includes hardware research and also application development. Now my team member Vaishnavi will continue.
Now I am introducing about history of the quantum physics. In 1982, Feynman proposed the idea of creating machines based upon the quantum mechanics instead of the laws of classical physics. In 1985, David Deutsch developed the quantum Turing machine to show that the quantum circuits are universal. In 1994, Peter Shor came up with the quantum algorithm to factor the very large number to polynomial time. In 1997, Love Grover develops the quantum search algorithm with the O root of n complexity, and all this, and going through all these continuous experiments, we finally got the present form of quantum computing. Now my team member Akshaya will continue this.
Till now we have seen what quantum computing is and how does it works. Now let us see how does a quantum computer works. So quantum computer is basically a machine which works on the fundamental particles of physics that are electrons, neutrons, protons, etc. And it is not at all a super version of quantum classical computer. A classical computer generally works on the basics of electrical impulses, which converts the information into bits and all. But unlike a classical computer, quantum computer usually works by using quantum bits or qubits, which can stimulate simultaneously both the values for example, a classical computers generally stores the information in zero or either 0 or 1, whereas the quantum computer or qubit stores both in 0 and 1 simultaneously. For example, if we take if we play a game in a normal classical computer, we can see the mean chances of winning on a flipping of a coin is 50%. Whereas if we play the same game with quantum computer, the quantum computer winning is 97%. This is due to the proximity of quantum calculations by quantum computer. In classical bit, we can see it can store either in 0 or 1, whereas a qubit can store multiple values, which is generally referred as superposition. And one of the quantum bit can also calculate this because it can store maximum probability of winning. For example, the chances of winning like 90 to 10, 80 to 20, 70 to 30, etc. And at the end, it recover whole 0 or 1 or heads or tails, and thus the quantum computer wins. Now let us see some applications of quantum computer. My friend Anvisha will continue.
So now we're going to discuss on the topic quantum superposition. Quantum superposition is the phenomena where in the quantum world there exists a particle. There exists a particle where it consists of multiple states at the same time. multiple states at the same time when it is observed or when it is measured. So let me give you an example. When you toss a coin in the general world, it either lands on heads or tails. But in quantum world, the thing is, the win state will either give heads, and it will give heads and tails both. So this strange state is called superposition. Now, if the quantum and now we're going to discuss on quantum entanglement. So quantum entanglement means that when two particles are deeply connected, then the state of one particle is instantly links with the state of another particle, and it does not see the distance between them, no matter how far they are. Then quantum teleportation is a phenomena where the quantum state of a particle changes its location from one state to another state. Now my friend Anvisha would like to continue.
Let us know some applications of quantum computing. Cryptography, breaking RSA and ECC encryption. Quantum computers can solve hard mathematical problems like factoring numbers, and these are done much faster than classical computers. And quantum key distribution, it enables the secure communication through protocols like BB84 and E91, etc. Drug discovery and healthcare. Quantum computers are used for discovering new drugs and predictions of diseases. These are used it is used to analyze the genetic data. Next, in finance, risk analysis. Quantum computers can enhance risk analysis. Quantum computers can enhance risk analysis in finance, and it is more efficiently when compared to normal classical computers. And in option pricing, and more applications for quantum computers are cybersecurity, machine learning, and with the predictions. My friend Sankitna will continue the topic.
Disadvantages of quantum computers: harder to control quantum particles. Quantum particles are difficult to control due to their sensitivity and leading to errors, and their need for complex error correction, and lots of heat. Quantum computer generates a significant heat due to the extreme cooling system to maintain a absolute zero temperature, and expensive. Quantum computers are cost due to the advanced technology and specialized hardware and complex cooling system, and difficult to build. Building the complex quantums are difficult due to the advanced technology, and not suitable for word processing and email. Quantum computers are not suitable for word processing like word processing and email, as they are designed to complex providing problem solving system. Complex hardware schemes like superconductors. Quantum computers depends on complex hardware schemes like superconductors, which are cost difficult to build the errors. Anirudh will continue, give the conclusion.
Now I conclude that the quantum computing is the better way as when compared to the classical computers, because it executes programs and problems very easily with a brilliant quickness. And I also mentioned that this is also a tougher task to develop this quantum computing, because it is too expensive, and also it requires a lot of technology, which in our days we are lack of this in terms of quantum computing. But if we compare the use of this quantum computing with the classical computer, the quantum computing is the best one which is ever seen. This also the applications of the quantum computers are like finance, maybe like cryptography and healthcare, and also used in few other ways which are a bit easier than the classical computers. As the earlier stages, we face the problems like expensive technology, and this technology requires a lot of work. We are in the progress to implement this quantum computing, but it takes much time to develop this. But this is the better technology when compared to the classical computers. Thank you.